Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 62, maximum number of ways to partition an array. So this one is pretty hard for me. I actually got the idea pretty quickly, I thought, but I had a lot of off by ones. And I think that's my general advice, is that if you see yourself having off by one, step back and really think about what every index means and be very precise about it. I didn't do that this contest. I usually am better about it. Maybe I blame it on the jet lag, but yeah. So give me some support by hitting the like button, hit the subscribe button, join me on Discord, and let me know what you think about this problem. And on Discord, a lot of people talk about the contest right afterwards, so that'll be fun for you and me, maybe. Anyway, so the first thing to notice, so how I attack this problem during the contest, and you can watch me solve it live next, during the contest, is that I looked at, anytime you see something like this, you know that I had to do the prefix sum and in this case the suffix sum in some way, and that's basically what I did. I wrote some, and you could watch me solve it live next during the live portion, but basically what I did was that I wrote code to kind of print out the prefix and the suffix and kind of see if I could get any pattern about it, right? And then I asked myself, for example, in this case, and you can actually see me do this during the contest, but basically I have a debug function that I print out. Actually, I didn't even need this, but yeah, so I print out the prefix and the suffix, and then I later add on delta for a reason that I'll explain in a second. But yeah, but let's just go over that for real quick. And basically for the contest 3, the example 3, you have this thing, right? So I ask myself, okay, so what does this prefix suffix sum represent to me, right? Well, in this array, every zero means that everything to the left. So okay, so we have the prefix array, right? So the prefix array means that this index, the -35 for example, let me put in the input as well so we can kind of visualize it. So let's actually also add labels. So yeah, I know that I sometimes do drawings, but I don't know that this helps for this one, so I'll go over this in a second. Hang on, type this out. But this is essentially what I did during the contest to try to figure out how to visualize it. And there are a lot of ways to visualize a problem, right? Sometimes you write code, sometimes you use pen and paper, and sometimes you do, different things. So for this one, what I did was I actually print out the array. So yeah. So this one, you see that this is the nums, and the prefix is just prefix sum, is a prerequisite for this problem probably. So definitely, if you have any confusion here, definitely spend some time doing prefix sum problems and see how you can figure it out. So in this case, we have the prefix sum, and yeah. And the idea here is that, for example, this -34, what does that mean? Well, 34 is in the 5th index. That means, or the 6th index, I'm going to go at that, but index 5, that means that this is the sum of the first 5 elements, right? So these are prefix sum stuff, and that is basically what it means. And 0 means no element in the beginning. And the same thing for suffix, we have 0. That means this is, the sum of the last x elements. So you have -14, -13, and that means that this is -27 and so forth, right? So prefix, suffix, sum. The idea here is allow us to query very quickly what is the sum of everything to the left of something and everything to the right of something, right? And this is critical because that's basically what we want to do. We're going to get the sum of the first n elements or x elements, and then the sum of the last x or y element or something like that. And the prefix and the suffix lets me do that. And I kind of did this to visualize very quickly. And then the next thing I did was I brute forced myself a little bit for small queries of, okay, let's say for example, on this one, let's say we switch k is equals to -3. What does that mean, right? So I did something like, okay, nums of 2 is equal to k. I mean, this is way hacky, but I just wanted to visualize, right? So then now we have this as the nums array, and then we have the prefix and the suffix. What does that mean now? So this is the prefix array, and we have all this stuff, and we have the suffix array, which is the same thing, right? And then I noticed that, that after you switch the prefix and the suffix, you can actually, I mean, and you have to do some off by 1 to match up, but you can see that if we just subtract the differences, we have this delta array, which is the difference between the prefix array and the suffix array, right? And the key thing to know here is that now you have zeros, right? And what does these zeros mean? And as we said, the 0 here means that this is the difference between, and you have to say it every index, and I messed up here during the contest, which is why I have so many wrong answers and just whatever, because I did it quickly, I think, relatively. But for example, this 27 means the prefix of the first 4 elements, right? So that's these 4 elements. And this 27 means the prefix, or the suffix of all the other elements on after that, right? And that means that if this is 0, that means that the prefix and the suffix match perfectly. And that's basically what I have here, right? Yeah. And then the question, so now we have a solution, or a tentative working solution, even though it's not going to be fast enough. Because basically, if we for every index, if we change it to k, that means that now we have to just count the zeros in the delta array, right? So we have a solution. It's not fast enough. It's going to be n squared, because if you switch it for every number, it's going to be too slow, because n is 10 to the 5th. So then now, the second part, which is a bit harder, is try to figure out, okay, how does this delta array react to change, right? And that's basically, and you could see me do this during the contest as well, is that I actually print out, I actually brute force this. Yeah, that's actually, that's, and I actually did this during contest as well. So it's not just me kind of writing something for you. It is actually how I did it during the contest. Yeah, right. So I have this thing for debugging. Let's actually just copy and paste this instead. We don't need this anymore. Yeah, and then yeah, just adding a debug function, and like I said, I did this during the contest. So yeah, and then now we can do debug of nums, and then we can do for x in range of n debug num sub x, right? So then now we run it again, the debug code. Ooh, did I have a typo? Oh, I forgot to press this. Oh, if I is not none. I actually did it correctly during the contest, but yeah. But now you have all these. Okay, let's make this slightly friendlier as well. So yeah, so now, now we we'll have to get rid of this one. That's why it looks a little bit weird. But yeah, now we're looking at, okay, now we have this visualization of everything that the transition, right? And the thing that it takes some time, maybe some practice, but then it's a simple question, right? Let's say we change the first element from 22 to -33. What does that mean? That means that on the prefix sum, everything to the right of this prefix sum is it's minus 55, right? Because here 22 to minus 33, you subtract 55, I think, or whatever it is. That means that all the prefix sum to the right of it is, including this element, is going to be minus 55, right? And you can kind of see that here. And what does that do to the suffix, right? That means that it only minus 55 on the left, because yeah, it minus 55 on the left because because everything here does not include the first number, right? So there's only minus 5 here. But what that also means is that now you have this delta of prefix minus suffix. This delta means that if you kind of work your way element by element, everything to the right here is plus 50. Everything to the right is minus 55, and everything to the left is plus 55, right? I think if you have trouble understanding this part, definitely just slow down and then think about it again, because I don't think this is a tough concept to understand per se, but it does take time for the light bulb to click, because that's what it took for me. Like, if you watch me during the contest, I actually spent a lot of time making sure I really understood this. But basically everything to the right of the the prefix array is minus 55. Everything to the left of the suffix array is minus 55, but as a result, the delta means that everything to the left of it is plus 55, and everything to the right is minus 55, right? And this is the same thing here. If you change the second element from 4 to 33, then this is same thing. This is minus, what is it, 17? Oh, this is this is going no, this is going from here to here. That's why I was confused. Okay, yeah, so this is minus 37 on this side, minus 37 here, so that means plus 37 here, minus 37 here, right, on all these numbers compared to this original non-altered one. So then now, you can kind of see the pattern of just this. And then the question is, how do you use this information, right? Well, the way that I did it is that I look at this delta array, and then I just split it into two pieces, right? So in this case, for example, I have, this is my delta array. If I change the first element, then I have basically this thing, these two parts, and here I wanted to, let's just say we have the difference as you go, and you can actually see my code here, but yeah, let's just say the difference is basically replacing num sub I with k, so this is the difference. So then here on the left, we want to add everything on the left by we want to add it to, let's just call it d for now. So everything on the left, add d. Everything to the right, we subtract d, right? And after that, after we do all that, we count the number of zeros, right? And that's basically it, really. I mean, there's some off by one stuff that, I'm not going to go into, but that's basically the hard part and the logical part, right? Is that now, okay, so then now, for every element, what I do is, okay, let's say now this is 46 is done, so then now we just move the 90 to the left, and then that's it. Yeah, and then we move 90 from the right, and then now we check again. We add all the elements to D in here, and subtract D from all these elements. And you don't actually have to do the subtraction, right? Because now what I did is, okay, now I think it's a good time to go over the code. We have the debug code that we just put in. But let's remove this just for clarity. Hopefully I don't need it because then I don't want to type it again. But yeah, now you have the prefix, you have the total sum, and then basically we just do this to calculate the prefix and the suffix array, and then this is the delta array, which is just x minus y for every one. This is just for me getting the case in which in which the initial, you make no changes, right? So this is the case, no change case. And then now here, we just keep a count of all the, because here we don't really need an array of all these elements. We can just look at the frequency, right? So for the left, we start with nothing. And then on the right, we start with all the suffix on the delta. And then for every one, we look at the difference. We calculate this D that we talked about. And on the left, instead of literally adding D to every element, we just count the number of elements that if we add D would make 0, right? Here, so basically, instead of adding D to every element, we ask, what do we need to get 0 if we add D, right? And of course, that is just 0 minus D, so that's negative D. That's why I have negative delta difference here. And also on the right side is the same thing but opposite. So, you know, we ask ourselves, what do we need to get 0 if we subtract D? So then that's why I have the difference here. And then after that, we process moving it from, you know, an element from left to right. And that's pretty much it. Yeah, like I said, there's some off by one type thing, so I urge you to kind of think about it. But that is basically the solution. And I spent way too long just on off by one. I think I had this answer, roughly speaking. My first submission was at 30 minutes. So I spent about half an hour plus 3 wrong answers to debug because I was rushing it and was being a little silly. Such is life. But yeah. That's all I have for this one though. You can see that this is linear time, linear space, because we just do a lot of linear operations here. We do another linear operation here, another linear operation here. This is linear space at the worst case, but in either case, all these are linear space anyway. So linear time, linear space, and that's all I have. You can watch me solve it live next, and I think with this one, I mean, you could watch it on a faster speed, but I think I gave a good approach on how I did it, or attacked the problem. Even though I got off by 1 and I really, well, that part I'm not proud of, but yeah, let me know what you think, and you can watch me solve it live next. Does it have to be related to 0 or anything like that? What is K again? Oh, 2K, okay. So you can't just change it to anything, you have to change it to K. And it's 2 to 5. Let's see. So how many pivots are there? So here, how do we count? What is the best way to count? Do they have to equal to 20? Oh, to 0, sorry. I don't know why it says 20, but okay, that's a little bit rusty. Does this give me a generator? Yeah, okay, it does. Okay, so why? Now, just for fun, was it the third one? Yeah, okay. What does that prefix sum look like? 1, 2, 3, 4. So that means that okay. So the 4. So that means that this is equal to this, this is equal to this, and this is okay. I think this is just a lot of math, but change it back to 25. So can I suss anything out here? What does changing a number mean? So we have the suffix sum. Changing a number, changing this number, what does that mean? Let's see. Just visualizing it. So changing this number from 25 to 33 means that every number afterwards is -8. The suffix doesn't change. Well, the suffix means that every prefix is also -8. Okay. Or the prefix of the suffix is -8. Okay. So that means that by changing the number, okay. Did anyone solve it yet? I have such a tail, because this is such an easy-ish contest that I think that 5-minute penalty, yeah, such a low ranking as a result of that 5-minute penalty. And people already finished. But what can I gather from this? Okay, just matching up the arrays. Match up the arrays. Right. Why did I just type it out? It's a little bit slower, but oh, I didn't. Whoops. Okay. So that we see 8 happens times. It is 0 4 times, which is obvious. So basically, we want to minus. Is it every array by 8 in this element? If that's the case, no, this is +8 on the left and then -8 on the right, right? So basically we have this thing. Okay, so I mean, I think this is doable in an hour, but there's just a lot of keeping track of math and bookkeeping at this point. I think I have enough to solve it. It's just about taking the time. And yeah, because okay, we start with this, right? Count the number of zeros. Okay. And then we change the 22 to 33. What does that mean? Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord, especially if you like contest problems, come and hang out and chat about contest problems after the contest. Anyway, I'll see you later. Stay good, stay healthy, to good mental health. Take care of yourself. Bye-bye.